Hello everybody and welcome to this extension video to the thermal physics topic. Now in this video what we're going to be doing is having a look at a couple of the different scales and units that can be associated with thermal physics. Realistically, some of this is beyond what we need to know for A-level, but I think just for a little bit of an extension and a little bit of extra information, it's always worth knowing. So the first different unit we're going to look at then is a different temperature unit to what we may be used to, which is known as the Fahrenheit scale. Now the Fahrenheit scale used to be used here in the UK quite a lot. Really over the last few decades it's been superseded by the Celsius scale, but if you talk to some of the older generation, so maybe your grandparents or if your great-grandparents happen to be alive, then they may well think and be able to understand the Fahrenheit scale quite well. Now of course the Fahrenheit scale itself, from a temperature point of view, is still the prominent scale in the USA. That's the scale that they use all the time, so if you happen to watch any weather forecasts from America, it will all be given in Fahrenheit rather than degrees C. Now of course when we remember back to the Celsius scale, there were two key points on the scale that we set. They were of course the melting point and the boiling point of water, of H2O, and then we decided there were going to be 100 scale divisions in between. Now the Fahrenheit scale was written in a similar way. 2 points were chosen by Fahrenheit. Fahrenheit was a Dutch physicist, by the way. So 2 points were chosen, and then he decided the scale divisions in between. So on the Fahrenheit scale, here are the 2 points. Firstly, the point 0 degrees Fahrenheit was defined as the freezing point of a mixture of water and salt, so sometimes known as brine. So freezing point of brine. Okay, so brine is just a salt solution. And then Fahrenheit chose 96 degrees Fahrenheit as human body temperature. Now, the reason why Fahrenheit chose 96 as his scale division is because if you do the maths, 96 as a number has got a lot of factors. So just like 12 has got factors 1, 2, 3, 4 and 6, and actually as a counting system makes a lot of sense. 96 of course is 8 times 12, so 96 has got a lot of factors and obviously a lot more factors than 100 does. Now in order to do your conversions, if we are going from degrees C to degrees Fahrenheit, you notice that we do use the degrees sign for Fahrenheit as well. Then what we're going to do is we're going to take the degree C, we're going to multiply it by 9/5, and then we're going to add 32. In order to go from degrees Fahrenheit to degrees C, we're going to do the opposite, so we're going to subtract 32, and then we're going to divide by 9/5, okay, or of course you can multiply by 5/9. Now of course the 32 here comes from the conversion that 0 degrees C is the equivalent of 32 degrees Fahrenheit. And actually that number 32 was again deliberately chosen by Fahrenheit because if you have a look at the difference between the melting point of water at 32 and human body temperature at 96, then you'll notice that the difference there is 64 degrees Fahrenheit, and of course 64 is a power of 2, so again it makes the intervals nice and easy to work out. Now, of course, the Fahrenheit scale, as we said, has really gone out of fashion in most of the world now. It does have, though, one specific advantage over the Celsius scale in that the scale divisions are a lot smaller. So a difference of 1 degree Fahrenheit is a lot smaller, is 5/9 of a difference of 1 degree Celsius. So the Fahrenheit scale does, in a way, give you a better resolution. But of course, as I said, the Fahrenheit scale has really fallen out of fashion, and the Celsius scale tends to be the one that the vast majority of the world uses, purely because it's a lot easier to understand with respect to water. Nice easy numbers with respect to water. We can understand that 0 is melting point and 100 is boiling point, and obviously 100 definitely fits into the more decimal approach that we take with units nowadays. Next then we come to pressure units, and the first key pressure unit that we're going to look at is what is known, the abbreviation is ATM, and it is known as the standard atmosphere. Now the standard atmosphere is a way of measuring, not exactly, but it is a way of standardising the atmospheric pressure that we have here on the Earth at sea level. Now, of course, it's very difficult to get an exact value because, of course, pressure changes all the time depending on where we are, and obviously we know full well that the pressure dictates the weather to a certain extent. So it's quite difficult to define from that terms. If you look into it in a little bit more detail, the atmosphere is defined a lot more rigorously than that, but obviously we won't necessarily go into that in this video. Now, the conversion is relatively straightforward. 1 atmosphere is 101.325 kilopascals. Okay, so just over 100 kilopascals. That's just over 10 to the 5 pascals. So that's a relatively easy unit to understand. Now, actually, if you look at the atmosphere and you go back historically, it was in fact defined in terms of another unit. And here is the symbol for the unit, which may look quite unwieldy, but what this one means, mmHg, you might recognise the Hg bit, and this stands for millimetres of mercury. Now this, again, quite an old school unit here. How millimetres of mercury was originally defined is if you take a very thin tube, okay, which would be sealed at one end, and if you put some mercury inside the tube, okay, just like that, then obviously what would happen is that the weight of that mercury would push down on the air that was below it and would exert some extra pressure on that column of air that's trapped underneath the mercury. So the millimetre of mercury was defined as the extra pressure. Obviously I'm talking weight, there's your force, and you would very easily be able to calculate or measure the area or the surface area of that little column of mercury. And what the millimetre of mercury did is it said that if you had a little column of mercury that was 1 millimetre high, what would the extra pressure on the air in the tube below it be? And that's how the millimetre of mercury was defined. Now, to give you some equivalencies here, so 1 millimetre of mercury is 133.3 pascals, and when you work that out, when you work that through, it means that 1 atmosphere is 760 millimetres of mercury. Now, again, as I said, that's a relatively old school unit that, at least in physics nowadays, with SI units, we obviously want to use pascals, and therefore we don't use millimetres of mercury anymore. But actually, you'll probably have seen, or at least your parents would have seen, that as a pressure unit being used, maybe some more often than not. It's still used in medicine quite a lot, and actually, whenever you have your blood pressure taken, they give you those numbers, so hopefully it'll be 120/80 or something like that. Well, both of those numbers are actually quoted in millimetres of mercury. So next time you're at the doctor's or something like that, if they do your blood pressure properly, the old school way of doing it with the cuff and the stethoscope, listening to your pulse, through your elbow, through your arm and all that kind of stuff. Have a look at the gauge and hopefully you should see those letters MMHG on there. If not, of course, you can always either wow or confuse your doctor when you ask them if they know what the unit of blood pressure is. If you do, let me know. I'd love to hear if you have done that, and we'll see if we can test some of our doctors or anything like that in that way. Next then we're going to have a look at volume. Now volume in more general terms we've had a look at in one of the math skills video, but of course there's one particular unit for volume that we need to make sure we understand from a gas point of view, which is of course the litre. Now the litre is a measure of volume, and it can be used for liquids or gases very commonly. Now, maybe from chemistry you'll recognise that 1 litre is defined as 1 decimetre cubed. Now of course 1 decimetre is equal to 10 centimetres. In other words, if we define the litre, if we draw a box where the dimensions are 10 centimetres by 10 centimetres by 10 centimetres, that would be the definition of a litre. Now, if we've got 10 centimetres by 10 centimetres by 10 centimetres, that would therefore be 0.1. That's obviously metres, and we're going to cube that. And therefore, 1 litre is the equivalent of 0.001 metres cubed. Now, of course, if you flip that round, what that means is that 1 metre cubed is therefore 1,000 litres. Now, of course, from a water point of view, remember that the density of water, and that's obviously water in its liquid form, is 1,000 kilograms per metre cubed. Now, of course, if you realise that 1 metre cubed is 1,000 litres and 1 metre cubed is also 1,000 kilograms, it gives you a very nice relationship that 1 litre of water has a mass of 1 kilogram. So that's why the decimetre cubed or the litre is a very convenient unit of volume, because it means that when we're talking about water, 1 litre of it has a mass of exactly 1 kilogram. Finally then, we're going to have a look at a couple of industry standards. So these are obviously used in a lot wider spheres than just physics, and obviously chemistry as well. Now, STP stands for standard temperature and pressure. Whereas NTP stands for normal temperature and pressure. Now, normal temperature and pressure we'll have a look at first. The pressure that we take for normal pressure is very simply 1 atmosphere. So in other words, our standard 101.325 kilopascals. And then for normal temperature, we take 20 degrees C. Now those two values are supposed to represent some form of average across the sort of natural surface of the Earth. So that's naturally the temperature on average, and naturally the pressure on average across the surface of the Earth, as I said. Now for standard temperature and pressure, we make the numbers a little bit simpler. For the temperature, we take 0 degrees C, and then for the pressure we take 100 kilopascals, and that is known as 1 bar. So there's another pressure unit that we can just slip in there, and we can say that 1 bar is equal to 100 kilopascals. Now standard temperature and pressure tends to be more widely used, especially, as I said, amongst the scientific community, but you know, really just showing you that if you see those letters STP or NTP, you'll know what they mean. So that's it for this video, really just to give you an idea of some of the other units that you may come across, depending on which career path you decide to go down. You may end up seeing one or two of those at some point, or to give you maybe a little bit of understanding, especially of something like millimetres of mercury, which of course your doctor is quoting your blood pressure at. So while that is a little bit beyond A level, I hope you found that a little bit useful to see some of the other ways that we can go about measuring, especially when we talk about gases, the ways we can go about measuring all the different variables to do with gases that you may end up seeing at some point. So that's it. I hope you enjoyed the video, and of course I hope to see you in a future video.